Okay, today we're talking more quadratics. Okay, so in math, your different functions, your different graphs, right? They have their own special form, right? You can look at a formula and you can decipher basically what the graph is going to look like based upon the equation that you're seeing, right? Eventually, maybe not now, but eventually in the future, once you get through college algebra and or pre-calculus, right, all of these are part of sections of a cone. Okay, so the standard form, right? This is what we're used to seeing for a quadratic: ax squared plus bx plus c, right? That's your standard form of a quadratic, where a, b, and c are all numbers, right? Those are your coefficients. Well, there's another form that you could have your equation in called vertex form. Okay, and this is what they're calling vertex form. And what's neat about mathematicians is that they're not very creative. So if we have a graph or an equation in vertex form, then that means you can pretty much know exactly what the vertex is by looking at the equation. And since the vertex is a pretty important part of your parabola, right, that's the graph of a quadratic, is the parabola, it's kind of nice to know what the vertex of your equation is. Okay, so remember, the vertex of your graph is either a maximum or a minimum value, depending on whether your graph opens up or opens down. So the vertex in this case is going to be the minimum point of your graph. It's also called a turning point, where the graph turns from the y values are decreasing, right? The y values are decreasing from left to right, decreasing, 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 and then we get to the vertex, and now the y values start getting positive, or start increasing, right? They start getting greater as you go to the right. So this is called a turning point of your quadratic, or a turning point of your graph. There's some calculus that's pretty important about turning points, or points of inflection. So from your equation, we can directly identify the x-coordinate. So the x-coordinate is inside of your parentheses with the x, and the y-coordinate is on the outside of your parentheses away from the x. Okay, and some things to notice is that in the equation, there's always a minus. The equation has a minus with your x and your h. But if we come over here and look at the value of your vertex is a positive, right? So we have a minus here, doesn't mean that this is a negative value. If this is a minus in your equation, then our x-coordinate is actually positive. And we will learn through Algebra 2 and some other things about transformations that the transformation is opposite of your sign. So if you have a minus in parentheses, that means you have a positive or a right transformation. And if you have a plus in here, that means you're going to have a negative or a left-forming transformation. Okay, so these first couple of problems are just saying identify. Get used to this format that the vertex is found in. Okay, so here is our first one: x minus 8 quantity squared plus 10. So if this is a minus 8 here in parentheses, then your x-coordinate is going to be a positive 8. And if this is a plus 10 out here, that means we have a plus 10. So the y-coordinate is exactly what it looks like. If it's a positive, if there's a plus, then you have a positive y-coordinate. But if there's a minus inside of with your x, then it's also a positive. Okay, so the x's are always opposites and the y's are always the same. So we have a vertex at the point 8, 10. Okay, number 2, we have a plus 15, which means our vertex has an x-coordinate of negative 15. And we have a minus 4, so the y-coordinate is a minus 4. Okay, the x-coordinates are always opposites, and the y-coordinates are always the same. Okay, number 3. What is the vertex coordinate for number 3? The x-coordinate is the opposite of the sign in parentheses, so it's a -3 in parentheses, so a positive 3x coordinate. And the y-coordinate is the same as the sign after. Right, so remember this 2 and this negative don't have anything to do with your vertex. This is about how narrow or how wide your graph is going to be. Okay, number 4. What is our x-coordinate? -5, right, because it's a positive, it's a plus in parentheses. And do we have a number after the parentheses?
No.
We do not, so that means we have a y-coordinate of 0. Okay, you should always, well, maybe not always, but if it's missing a part, then that part will be represented with a 0. Okay, number 5, we have a +6 and a +12 as your coordinates. Okay, a minus in parentheses means a positive x value, and a +12 means a +12. And our last one of this sort, we have a vertex at -20, -1. Okay. A plus in parentheses means we have a negative coordinate, and of course a minus after means we have a minus coordinate. Okay, so that's just using our eyeballs, right? We are using our eyeballs in identifying the x-coordinate and the y-coordinate based upon the equation, or based upon, the equation that you're given. So identifying the vertex, pretty easy to do if we have our graph in vertex form. Okay, so now here comes the algebra. To convert from vertex to standard form, okay, in my opinion, standard form isn't that helpful, but that's just my opinion. It's usually how we start off, and this is a good practice of some algebra. Use the box method to multiply, and then distribute and combine like terms. Okay, so however it is that you want to multiply, that's how you're going to do it. So if you like the box method, great. If you want to distribute double, that's great too. But the understanding is, and this is what's the matter with a lot of things around the world, what does it mean to square something? Okay, this is where your understanding needs to come in. What does it mean to square something? So we can rewrite this if we want to in longhand, and you don't have to do this, but x minus 4 squared means x minus 4 times x minus 4, right? And then we still have the +12. So PEMDAS says we have to do our parentheses first. So we're going to multiply these two things together. Okay, and there's lots of ways to do it, so whatever your favorite method is, okay, you can do double distribution like this, right, where you're multiplying each of your first terms by those terms. You can do what it said, the box method, right, where we draw our box and we have an x minus 4 this way and an x minus 4 that way, and you multiply them through, so that's the box method. Okay, either way, you have to multiply that parentheses by itself. So if you use the box method or the double distribution, right, this should be our product that we get, and we still have to remember our +12. So now it comes down to combining like terms. We have a couple of x terms that we're going to combine, as well as a couple of number terms. We have +16 and +12. So our last step to all of these problems is to combine our like terms. So we have x squared, minus 4x and minus 4x is minus 8x. And we have 16 plus 12 is plus 28. Okay, so this as a vertex form would convert to this equation in standard form. Okay, so what is true is if I were to plug in 0 into my equation, right, if I plugged in 0 here and simplified this out, I would get the same thing as if I plugged in 0 here. Okay? Mathematically speaking, these two things are the exact same. But they look a lot different, right? This one has parentheses and a power. This one has quadratic style. Mathematically, they're the same thing. Visually, they look different. Okay, so standard form to vertex form, and vice versa. Okay, number 8, we have a little bit more to do because now we have this coefficient, this -2 multiplier. But we don't start with that -2 multiplier. We start with doing our squaring. Okay, remember this means multiply it by itself. So x plus 5 times x plus 5. And then we still have your -3, and we still have to multiply it by -2 eventually, right? Eventually. Because PEMDAS says we have to do our multiplication, so we're going to distribute into there. Okay, that gives us x squared plus 5x plus 5 more x plus 25. And I still have to multiply everything by -2, and then eventually I'm going to subtract 3. Okay, so there's lots of ways you can do this, right? Mathematically speaking, if you want to, we can combine our like terms in here, right? That is definitely one thing that we can do at this point. That is perfectly mathematically legal, to combine our 5x and your 5x. Or if you wanted to, you could multiply -2 by all of these terms, right? Just like you see them. That would also be mathematically correct. Another way to do it. Okay, either way, we're going to have to do, well, that now, I guess. So now we have to multiply all these things by -2. And we either do it in the previous step or we can do it in this step. So -2x squared. And then a minus 20x, because -2 times +10 is -20. And then a minus 50, -2 times 25 is -50. And then lastly, we have this -3 still hanging out there at the end, which means we have one more set of like terms. So our very last step would be to add -50 and -3 to get -53. So this is our standard form of our quadratic equation given your vertex form at the beginning. Okay, so yes, there's a lot of algebra here. There's distributing, there's multiplication and combining like terms. All the things are involved in these problems. Okay, so there's a couple more problems here. Let's look at those ones. Number 9. Right, we have some options. A, B, C, and D are our options. So let's see what the right answer is going to be. Okay, first we start with multiplying by itself. X minus 8 times x minus 8. That's what this square means, multiply it by itself. Okay, so let's do that. X times x is x squared. X times -8 is -8x. Okay, we're going to get another one of these -8x terms. That always happens with these type of problems. And then we're going to get a plus 64. And all of this has a negative out front and a plus 10 at the end. Okay, so one way is to go ahead and distribute this negative to all of our terms. Okay, if we have a negative in front, that means all of these terms are going to change signs. Right, we're going to change signs. So it's going to be a -x squared, and then a plus 8x. And then another plus 8x and a minus 64. Right? We're changing all of the signs of the things in parentheses. All the positives become negatives and all the negatives become positives. And then we have our plus 10 still. Okay, so let's combine our like terms. We have 8x and 8x, and we have negative 64 plus 10. Okay, those are our like terms. So we keep our negative x squared. 8 plus 8 is 16x, and negative 64 plus 10 is negative 54. So let's see which one matches up with that. Not that one, it has a minus. Not this one, that's only 2 terms. It looks like C is the way to be. That one is the correct answer, at least for the math that we have done. Okay, which one of the following is equivalent, right? Well, same question means which ones are the same. Okay? So let's start once again by rewriting x plus 3 squared as x plus 3 times x plus 3, right? That's what it means to square something. We're going to multiply all of that by 5 and then eventually subtract 20 from it. So we have x times x, which is x squared. X times 3 is 3x. 3 times x is another 3x, and 3 times 3 is 9. Okay, and notice we're keeping all of this product in parentheses because all of it has to be multiplied by 5. Okay, so we can multiply all of these terms by 5 right now if you want to, which is a perfectly fine way to go to get rid of those parentheses. That gives us 5x squared plus 15x plus 15x plus 45. And then my last thing to do is minus 20. Okay, so combining our like terms, we have a plus 15 and a plus 15. That's plus 30x. Okay, I still have my 5x squared. And then my other like terms are my plus 45 and my minus 20, which gives me a plus 25. And my answer is going to be B, my simplified version. Okay, so some things to remember is keep your products in parentheses. Keep your products in parentheses so you can distribute your coefficient out front to all the terms in the parentheses. Okay, and then combine like terms, and then we have successfully gone from vertex form of a quadratic to standard form of a quadratic.